Oh my goodness, here we go again, guys. Let's do this. Solving applications. These are all about quadratics. We're going to solve some real life situations. The struggle's real. So let's look at example 1. At a swim meet, Jenny dives from a diving board that is 48 feet high. Her position above the water is represented by this beautiful quadratic equation, where x is the time in seconds and y is her height above the water in feet. After how many seconds does Jenny enter the water? Step 1, sketch a graph and label what each axis, x and y, represents. Okay, so let's discuss this. So we're going to sketch a graph. Okay, we're going to go in the calculator. We're going to hit y equals. Now, we've learned in class what to do, right, to type these in. So I'm not going to talk as much about how to type things into your calculator, only because we talked about it in class already. So boom, boom, and then plus 40. Okay, let's graph this. Wow, that's really high up there, right? I'm going to zoom out of this really quickly. There we go. Okay, so looking at this graph right here, let's first talk about, I can see it's going up and then coming back down. Let's first talk about what x and y represent. So y is the height above water. So this would be height above water. And this here is how many seconds. Wait, let's see. X is the time in seconds. Okay, so this is time in seconds. Boom. After how many seconds does she enter the water? Okay, well, let's look at this calculator again. Jenny's way up here somewhere. And I want to talk to you about how to look up here. This is the y-axis, right? Let's rap about this. This is the y-axis. I want to look further up the y-axis, right? If you click window, further up the y-axis, so you want your maximum on the y to be bigger. You can go in here and you can change your window. Now I'm pretty sure in our class we're going to tell you what to change it to. So I'm going to tell you right now, hit window, change your y max to 50. Okay? If you do that and then you hit graph again, suddenly we can see the whole parabola. Okay? So what you got going on, let's go ahead and wing it kinda. You got something like this going on. Now let's think about the situation. Jenny is diving, correct? Into the water, correct? This is the only part of the parabola that matters to our situation. Do you see this? Jenny's right here, chilling, about to dive, and right here is where the water is, okay? So that is what's happening right there. And now all they wanted us to do was sketch it. So we sketched it, height above water, time in seconds, we see what's going on. What are you trying to find? Well, it says how many seconds until she hits the water. Well, she hits the water right there. Label it on your graph. You want to find out where she hits the water. That's what you want to find out. So step 3, solve. Now let's talk about it. We already did this in class. This is a 0, right? This is a 0. So you want to know what is this 0 in the calculator. So again, you're going to hit second, trace. We've already talked about this one in class. Then you're going to hit 0. Put the cursor on the 0. So I want to find out where she hits the water. So that's where I'm going to put my cursor. Now hopefully I didn't go too far past it. Yeah, I have a tendency to do that. To get a little too crazy, you know. So we'll bring that back a little bit. Okay, it's back. So get it as close as you can to the 0. Can't really get it really close, right? So that's good enough. Go to the left a few times, hit enter. Get it back as close as you can to the 0. Go to the right a few times, hit enter. Hit enter on guess. 2.5. That's where our 0 is. So x equals 2.5. Now this is not how you would answer someone, right? So what's the answer to the thing? After how many seconds does Jenny enter the water? 2.5 seconds. All right? Make sure you write seconds with it. Okay? So all we're doing is taking what we know and we're applying it to a situation, finding zeros. American astronauts working on a space station on the moon toss a ball into the air. The height of the ball is represented by that beautiful quadratic equation, where t is the time in seconds since the ball was thrown, and y is the height of the ball in feet. So let's go on and do this. Real life situations happen in the first quadrant. Positive time, positive height, right? So looking at this, t is the time in seconds, and y is the height of the ball. So if this is the height of the ball in feet, then this must be t, the time in seconds. That's an ugly t. Time in seconds. Okay, so we've labeled the axis. It says, after how much time does the ball hit the ground? Round to the nearest hundredth of a second. Now, did we have rounding on the other one? No, it was all good. Okay. So let's go on into the calculator. We've went ahead and we labeled the axes. Let's go into the calculator. Let's hit y equals. I'm going to clear it out. Negative 2.7x squared plus 13.5. This is a really good time. Oh, and notice they use t. You're going to use x. Yeah, you know, your calculator uses x, so use x here. So x, and then we got plus 14. This is a good time for me to remind you, you can always go back and rewatch. You can pause me if I'm going too fast. It is within your control. You are in control of your education right here. So I'm going to go ahead and hit graph. Now, don't forget, I still have it set on that old window, which is fine. So what we're looking at is something right here, right? We're looking at this right here. So it looks like to me, it's something like this, right? But if this is the astronaut throwing the ball into space, this is what's actually happening, is this part right here, this first quadrant part, okay? And it says, after how much time does the ball hit the ground? Look at that question. After how much time does the ball hit the ground? We're going to label that right here. This is where the ball hits the ground. You're probably thinking, hey, Storvik, I don't want to write that. And I'm going to say to you, well, it tells you to do it. Look at step B. Part B, step 2, what you're trying to find, label it on your graph. Boom, where the ball hits the ground. Solve using a calculator. That's a 0 right there, folks. That's a 0. So we hit second trace. We're going to do 0. We're going to go try to put that cursor on the 0. Cursor moves like it's a Monday morning, I tell you. Jeez, oh, Pete. All right, come on, little cursor. You could do this. Ooh. Okay. All right, there's a 0 pretty much. Go to the left a little bit, hit enter. Go back to the 0. Go to the right a little bit, hit enter. Hit enter on guess. Now it said to round to the hundredths. Okay, hundredths are 2 places out. 2 places after the decimal. All right, 2 places after the decimal. So I'm going to look at this. I'm going to go 2 places after the decimal. So the 1 doesn't touch the 8, so that's 5.88. 5.88. So x equals 5.88. Now, 5.88 what? Clowns, cars, candles? I don't know why I'm using C's. I have no idea. But if we look at this, it says after how much time? And this says time in seconds, so 5.88 seconds. Done. All right? This is it, guys. I mean, this is what it's all about. It's all about using those zeros, but using them in a more real-life situation, okay? Remember, you could go back, you could rewatch, you could re-listen, you could do all of that. It's at your own pace. You're in control of your education. And until next time, bye!